Welcome back to this live lesson series on sequences. Today we'll be looking at how do we find whether a number is in the sequence, and if so, what term that number will be. Hopefully you managed to have a go at the starter questions. As always, we will start by going through these and looking at the solutions. So focusing on the top left question, you've been asked to generate the first 5 terms of 4n plus 6. So remember, it's really important that you know that n represents a term in the sequence. So if I want the first term, n is 1. Therefore, I can substitute n is 1 into my nth term, where I can say that 4n plus 6 would be 4 times 1 plus 6. 4 times 1 is 4, plus 6 is 10. So the first term will be 10. The next term will be simply, if you recall from sequences 2, this sequence is going up by 4. Okay, whatever is in front of the n is what the term is going up by. So I can simply add 4 to the first term to get 14 for the second term, add 4 again, 18, and all I have to do is keep adding 4 to get the next term, so 22 and 26. Okay. On the second question, you were asked to find the nth term for this sequence 2, 7, 12, 17 and 22. You have to first remember that you have to work out what this sequence is going up by, and as you can see, the sequence is going up by 5. So if it's going up by 5, we can write 5n. So our technique was to write 5n. We now need to work out what goes on the end of our nth term. So you simply write what it's going up by above the first term. So it's going up by 5, and then you check, how do I get from 5 to 2? Well, to get from 5 to 2, you have to take away 3. So our nth term is 5n minus 3, and you can always check if that works. Pick any term in the sequence. If we pick 17, that is the first, second, third, fourth term. 5 times 4 minus 3. 5 times 4 is 20, minus 3 is 17, which is the fourth term, therefore our nth term works. So the nth term for this is 5n minus 3. Okay. Bottom left question, find the nth term of this sequence. Again, same steps, find out what the sequence is going up or down by. This one happens to be going down by 3, so each time it is minus 3. So we can write minus 3n. Whatever the term is going up or down by, we write in front of n. Then you copy the difference above the first term, so it's going down by minus 3, so I write minus 3 above there, and check, how do I get from minus 3 to 5, because my first term is 5. Well, there, negative numbers is really important. Think about a number line. I must add 8 to get there. So minus 3 plus 8. Okay? And that will be that question done. Minus 3n plus 8. And again, you can always pick any term in the sequence and check if it works by substituting n for whichever term you're looking for. And finally, part of today's lesson will involve solving equations. So just a little solve equation question I'll put there for you. We're trying to get x on its own. Remember, the first step to solving an equation is to look at what is around what you need to on its own. We need x equals. Here, the first step would be to get rid of this minus 4. We do the opposite. We plus 4 to both sides. So we'd get 5x equals 12 plus 4 is 16. And then the last step to get rid of a 5x, so I just want x, we have to divide by 5, because the opposite of 5x means 5 times x. The opposite of times is divide. Dividing both sides by 5 will give us, now here, 5 doesn't actually go into 16. So you can simply leave this as a fraction. You should be confident in leaving solve an equation answers sometimes as a fraction. It won't always be a whole number. We don't have to work out the decimal. A fraction is just as good. If you really wanted to, given our fraction understanding, we could turn this into a mixed number, which would be how many times does 5 go into 16 whole? 3 whole ones and 1 left over, so 1/5. 3 and 1/5. Either of those answers are fine and perfectly correct. Okay, so that takes us on to sequences 3. Is a number a term in the sequence? So if we've got this sequence here, 5, 8, 11, 14 and 17, I've asked two questions. 1, is 35 in this sequence? And 2, is 108 in this sequence? Well, a really ineffective way to do that would be to keep writing out the next term until you get to 35 to see if it's in there. And even worse, you have to add whatever the sequence is going up by until you get to 108. That would be a really bad way to do this. I mean, it will get you the answer, but it's not a very efficient way. So what I want to look at today is how can we work out if a number is in a sequence using the most effective and quickest way possible. And this relies heavily on your understanding of the nth term. So if you haven't already, I highly recommend watching sequences 1 and sequences 2, because the understanding of those lessons will really help with what we're going to go through today. So I'm just going to make a new page. I don't want you to write this, so don't write this. Here we'll just explore different methods of how we could find out if a term is in a sequence and sort of boil it down to what works the best and what we're going to be using today. So I don't need you to write this, you can just sort of watch, and then when we go back to the worksheet we can start to fill in and follow along. Okay, so if we've got that sequence, which I'll just copy for us now. If we have got 5, 8, 11, 14, 17, and we want to know if 35 is somewhere in this sequence. Well, this sequence is going up by 3. Hopefully you can see that it is plus 3 every time. So the next term would be 20, the next term would be 23, the next term would be 26, then 29, 32, and 35. So yes, this term is in the sequence. So because 35 is quite close to 17, it didn't take me very long to add on 3 each time to get 35. However, if I want to check if 108 is in the sequence, I really don't want to be adding on 3 every time until I get near 100. It'll take me quite a while, and it's not a very effective way to do it. So we need to explore ways in which we can work out, is this term in the sequence, without having to manually add on or take away whatever the sequence is changing by. How we're going to do this is using the nth term. So we're going to use an easy example here where we already know that, for instance, 11 is in the sequence. So if I asked you, is 11 in the sequence? Hopefully you would say, yes, I can see it's in the sequence and it is the third term. Okay? First term, second term, third term. So you can see clearly, without having to work anything out, that 11 is definitely in the sequence and it's the third term. Well, if we relate back to the nth term, what do we know? We know that n represents a term in the sequence. So we could say that this, n is 3. The 11th the number 11 is in the sequence and it's the third term, which means n is 3. Okay. And hopefully if you understand all of the stuff in sequences 1 and 2, you can make the link that the third term simply means n would be 3. Okay. Well, how can we link this to the nth term? Well, what is the nth term? First of all, we should work out the nth term of this sequence. It's going up by 3. Okay, so we could say 3n. 3n. 3n is our first part of the nth term. Remember, you then write what's going up by above the first term, so it's going up by 3. So how do I get from 3 to 5? I add 2. So my nth term is 3n plus 2. Okay, 3n plus 2. So how am I going to use the fact that I know 11 is in the sequence and it is the nth, n is 3, it's the third term, with my nth term? Well, we simply can make our nth term equal to whatever number you are looking to find. So in this case, we're looking to see if 11 is in the sequence. So if I make it equal to 11, okay, I can then see that I've got an equation that I could solve. And if I solve this equation, what am I finding? I'm finding n. If I solve this equation, it will give me n equals. And we know n represents a term in the sequence. Okay, so let's solve this and just see what happens. If I solve this, the first step would be to take away 2 from both sides, which would leave me with 3n equals 11 minus 2 is 9. Then divide both sides by 3. N would be 9 divided by 3 is 3. Oh look, n is 3. What does that mean? That means 11 must be the third term in the sequence, because if n is 3, n represents the term in the sequence, which means if n is 3, it's the third term, which we can clearly see. We're using an example that we already know to be true to prove that this works. Okay, so it is the third term because n is 3. Now, if you think about how the nth term works, what do we say? We say n is 1, 2, 3, 4. We say the first term, second term, third term, fourth term, fifth term, blah, 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 etc. Okay? We never say half term, so what we can see here is n, for a term to be in a sequence, n must be a whole number, because you only get the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, 20th term, 50th term, 100th term. You never have a decimal, as you don't have the 5.5th term. It is only ever whole numbers. So we can use all of this understanding to help us decide whether a term is in the sequence or not. So we'll flick back now to our worksheet where we can follow along. Is 35 in the sequence? Well, the first thing we're going to do, and we'll do part 1 on this side. The first thing we need to do is find the nth term, which we've already done, remember. It's going up by 3, so it's 3n. And then if I write 3 above the first term, I can see it's plus 2. So 3n plus 2 is my nth term. Okay, and I can make that equal to whatever I'm trying to find. In this case, I'm trying to find, is 35 in the sequence? So I'm going to make it equal to 35. So I've made an equation. I've made an equation where I've got my nth term equal to what I'm trying to find. And I'm just going to write that down for you. This is the nth term, and I've made it equal to the number I'm trying to find, if it's in the sequence, okay? Well, let's solve it. Let's solve it for n. If I solve this for n, the first step that I need to do, hopefully you're comfortable with solving simple linear equations, is minus 2 from both sides. You may lay it out differently, that's absolutely fine. That leaves me 3n equals 33. And then I can divide both sides by 3. 3 into 33 goes 11, so n equals 11. Now, we have now answered our question. Is this term in the sequence? Well, what does n equals 11 mean? Remember, n represents a term in the sequence. This means that 35 must be the 11th term. So I can say yes, it's the 11th term, okay? Which I proved a second ago. I proved when I added on 3 each time, it would have been the 11th term, okay? So, I've made the nth term, or I found the nth term, I've made it equal to the number that I'm trying to prove whether it's in the sequence or not. I've solved it, and then I've realised if n is a whole number, if n was 11, that means it's the 11th term. So rather than having to add on 3 every time to check, I can make an equation, solve it, which will be so much quicker and more efficient than having to write out the sequence up to maybe 110, 200, 300, because they might not ask you something that is a lot higher than 35 in this case. So if we look at example 2 here, is 108 in the sequence? Well, it's the same sequence, so we can use the same nth term. So the nth term is 3n plus 2 equals 108. So I've made my equation. Now we can solve. The first step to solving, again, is going to be minusing the 2. So that will give me 106, because 108 minus 2 is 106. And I'll get 3n here. Divide both sides by 3. Now, you don't know your 3 times table at 106, so a bus stop would be useful. 106 inside, 3 on the outside. How many times does 3 go into 1? 0, carry the 1. How many times does 3 go into 10? That is 3 times, with 1 left over. How many times does 3 go into 16? Well, that is 5 times, with 1 left over. So as you can see now, because it didn't go into 16 whole, I'm starting to make a decimal. So this would be 3 into 10 goes 3 with 1 left over. Yeah, and I'm putting these zeros in placeholders. So I can see that it's just going to keep recurring. So there, my answer is not a whole number. So I can either write 35.3 recurring, or I could say n equals 106 over 3 is another way we can do it. We can leave it as a fraction. Both of those are correct, but as you can see, n is not a whole number. And if you think about what n represents a term in a sequence. First term, second term, third term, n is 1, n is 2, n is 3, n is 4. So if you get a decimal or fractional answer as n, then it cannot be in the sequence. You wouldn't say the 35.3 recurring term. It doesn't exist. It's the first term, second term, third term. You could have the 35th term and you could have the 36th term, but you cannot have the 35.3 recurring term. So whenever you get a non-whole number, not a whole integer as your answer, you can simply say, no, n must be a whole number, or you could say whole integer, to be in the sequence. Okay? So looking at those two examples, we've used the same sequence to prove whether 2 different numbers are in the sequence, and one of them was in the sequence. Why was it in the sequence? It was in the sequence because n was a whole number. N was 11. So that means it's the 11th term. So yes, it is in the sequence. In the other example, n came out to be a decimal or a fraction. It wasn't a whole number. So if n is not a whole number, you can simply say, no, n must be a whole number to be in the sequence. So here we have proved 2 different numbers to either be in the sequence or not in the sequence. So if we break this down into steps, because it's always good to have some steps to follow. What were our steps here? If we reflect back on what we've just done, the first step that we had to do was find the nth term. So that will be step 1. Step 1 will be find the nth term. So that's step one. If you have a sequence and you haven't been given the nth term, you have to find it yourself. The second step was we made it equal to whatever we were trying to find. So step two, make the nth term equal to the number you are trying to find in the sequence. So you take your nth term and you just make it equal to whichever number they've asked you to find. Okay. Step three, solve. We solved the equation. Okay, so very simple steps. If you've done sequences 1 and 2 in my lesson series, you should be able to do the first step. Step 2 is easy. You literally just make an equation, you just make it equal to a number. And step 3 is solving the equation, and hopefully you're confident at solving basic equations. So the last thing we should add here is, if n equals a whole number, then yes, it is in the sequence. If n equals a decimal or a fraction, so not a whole number, not a whole integer, then no, it is not in the sequence. So that's your last step. Once you've solved it, you'll have an n equals. You'll say n equals 10, yes, it is in the sequence, it's the 10th term. If it said n equals 5.5, no, it's not in the sequence. N must be a whole number for a number to be in the sequence. Okay, because remember, n is the term. Okay, so that is our steps. That's our sort of introduction to that. Hopefully you've sort of got to grips with where I was going with that, how I'm linking the fact that n represents the term in the sequence. We'll now look at 3 examples, and then you'll have an opportunity to practice them. Okay, so if we flick across now, if you can go on to example 1. I've asked, is 8 in the sequence 2n plus 3? So here, they haven't given you a sequence. They've actually made things easier for you because they've given you this. And you should straight away recognize this as the nth term. 2n plus 3 is the nth term of a sequence. And 8 is the number that they're asking you to find whether it is in this sequence or not. So we can simply follow the steps from what we've just written down. Step 1, find the nth term. Well, we've already got the nth term. We don't need to find it. They've given it to us, so even easier. Step 2, make the nth term equal to the number you're trying to find. So I'm going to make 2n plus 3 equal to the number I'm trying to find, which is 8. Step 3, solve. First step, take away 3 from both sides. That would give me 2n equals 5. Next step, divide by 2. Dividing both sides by 2 will give me n equals, well, does 2 go into 5? No. So I simply have to just either write what is half of 5, 2.5, or I'm quite lazy, I just leave it as a fraction, 5 over 2. I know that 2 doesn't go into 5 whole, so I'm just going to leave it as a fraction, 5 over 2. I'm just going to put here, just in case you don't like that, you could say or n equals 2.5, because half of 5, remember, is 2.5. Well, I've got a value for n now, and you should ask yourself, is n a whole number? No. 5 over 2, 2.5 is not whole. So we can simply say, no, 8 is not in the sequence. And what's my reason for that? Well, my reason is n must be a whole number. Okay? Because n is not a whole number, you know, first term, second term, third term, fourth term, n is 1, n is 2, n is 3, n is 4. I wouldn't say n the 2.5, I wouldn't say the 2.5 term, 2.5 term. So it's not in the sequence. And it's as easy as that. That is as simple as it is. You make the nth term equal to the number you're trying to find, solve the equation, and you decide whether n is a whole number or not a whole number by looking at your answer. So example 2. Is 7 in the sequence 3n minus 4? Well, again, it's actually been made a lot easier for you because they've given you the nth term. You haven't had to find it yourself. This is the nth term. Okay? What number are they trying to ask is in the sequence is 7. So again, following the steps. Step 1, make the nth term, 3n minus 4, equal the number you're trying to find, 7. Then we solve. So if we solve this, we're trying to get n on its own. So the first thing we're going to do is get rid of this minus 4 by doing the opposite and adding 4, which will give me 3n equals 7 add 4 is 11. Okay. Dividing both sides by 3. Well, hopefully straight away you realise, does 11 divide by 3? No. 3 doesn't go into 11, so I can just simply write my answer as 11 over 3 as a fraction. You could work out the decimal, but there's no point. You may as well just realise 3 doesn't go into 11, so my answer is going to be a fraction. Where do I go from there? Well, same thing as last time. Is n a whole number? No. So 7 is not in the sequence. N must be a whole number. Okay, you must have n as a whole number for it to be in the sequence. So again, nice easy steps to follow. Looking at example 3. Is 100 in the sequence 16, 20, 24, 28? Well, step 1, find the nth term. So here we haven't been given the nth term, so we have to find it ourselves. Now recall, how do you do that? First thing you check is what is the sequence changing by? This sequence is going up by plus 4 each time. So to find the nth term, remember, you write 4n because it's going up by 4. Whatever it's going up or down by, you write in front of the n. Then you write the 4 above, so what it's going up by, you write it above the first term. And you ask yourself, how do I get from 4 to 16? I add 12. So to get from there to there, I have to add 12. My nth term is 4n plus 12. So step 1, we've just done step 1, we found the nth term. Step 2, we have to make the nth term equal to the number we're trying to find. So we're going to make 4n plus 12 equal to the number we're trying to find. We can see clearly here is 100. So we're going to make it equal to 100. Step 3, solve. So if we solve this equation to find n, the first step we should do is get rid of this plus 12 by doing the opposite and minusing 12 from both sides, which will give me 4n equals 100 minus 12 is 88. Okay. Then you divide both sides by 4, so this is just basic solving equations. So n equals How many 4s go into 88? If you don't know off the top of your head, you can simply do a bus stop. So 4 into 88. 4 into 8 goes twice. Nothing left over. 4 into 8 goes twice with no remainder. So n is going to be 22. Now, n is 22, so you ask yourself, is n a whole number? Yes. So does this mean this 100 is in the sequence? It does. We can say yes, 100 is the, well, remember, n represents a term in the sequence. So if n is 22, that means this must be the 22nd term. So we know 1, we know it's in the sequence, and 2, we actually know which term it is. It's the 22nd term. So if you wrote out the sequence 22 times, so all the way up to the 22nd term, you would find that that number is in fact 100. And it saves you having to add on 4 manually to work that out. We've found it here. N is 22, therefore yes it is, and it is in fact the 22nd term in the sequence. So, if you haven't already, definitely go and watch sequences 1 and 2, because if any of that was a little bit confusing for you, that should clear up the nth term stuff that might have been new to you. Secondly, if you're struggling with solving these equations, you should go and look up some videos to work out how to solve equations effectively. I've done it a fair few times in the starters of a lot of lessons in my series, so you can sort of go back and have a look at those. But being able to solve an equation is really important. Knowing about the nth term is crucial, and knowing that n represents a term in the sequence is the key to all of this. Simple 3 steps. If you follow those 3 steps and you have either a positive or negative answer, a whole number or a decimal, I should have said, you know whether yes it is in the sequence or no it isn't in the sequence. Okay, so what I've got for you there are 10 questions to practice. I've given you the nth term to all of these, so you don't actually have to work out the nth term, because you should have done a lot of practice on that already. I'm just here, I just want you to practice making these nth terms equal to the number you're trying to find, solving and saying yes or no depending on whether n is a whole or fractional decimal answer. Okay, so hopefully you learned something. I'll link the answers to these practice questions in the description, and I will see you in the next one.